Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3. My name is Nur Hamizah binti Hamidi.
My name is Siti Suhaila binti Abdul Rahman.
Yeah, my name is Muhammad Akmal bin Karidin.
And my name is Niada binti Malila. Since that we didn't have the Raspberry Pi, so our project assignment couldn't do the hardware part, so we only do the software part.
In section A, I will show you guys about the Raspberry Pi simulator installation setup. In order to start the Raspberry Pi simulator, there are several procedures that we must follow. First thing, we must click the link given to download the VirtualBox software installation. Then, click the window host. And then start download. At this stage, I already download it. And you get your VirtualBox installation on your computer. After that, click the next link to start download the Raspbian OS image. At this stage, I also already download it. Then, we minimize the page and open the VirtualBox software. Click new to make your pixel and then name it as Raspberry and for type we choose lineup and for version we choose Debian 32-bit and then we click create and click create and go to set. After that, go to setting and choose storage and click empty. At the optical drive, we click pixel.iso and we click OK. After that, we click start. Okay, at start we'll choose pixel.iso and click start. Click view and choose scale mode and switch it. Customize your pixel to make it bigger. Wait for the loading. Click the terminal icon and then go to the assignment file and go to the number 10. The link is given, then rewrite the link given and after complete we press enter. Then write the code at number 11. Sorry for the mistake. My M is in small letter. It must be in capital letter. So I rewrite again. Then press enter. So that your Raspberry Pi is ready to use. Okay, that's all for part A.
Okay, first let we start to test using the terminal. Okay, first you need to write a VM start to know the information of your Raspberry Pi or computer. In the VM start, it will divide it 6 parts. For the first part is prox and then memory, swap, input output, system and CPU. Okay, for the props, it has RMB. For the memory, it has SWPD, free, buff and cache. For swap, SI and SO. For the system, IN and CS. For the input output, BI and BO. For the CPU, US, SY, ID, WA and ST. Okay, what is all about? First, R. R is the number of process waiting to the runtime. And then for the B, the number of process uninterrupted sleep. Okay, this is for procs. And memory, it has SWPD. Okay, SWPD is the number of virtual memory is being used. Okay, for the free, the amount of ideal memory. Okay, for the buff, the amount of memory used as a buffer. And then cache, the amount of memory used as a cache. Okay, for the swap, SI and SO. SI is the amount of memory swapped in from of this. Okay, for the SO, the amount of memory swapped to this. Okay, for the input output is divided into two, BI and BO. For BI, the block receiver from the. Okay, for the BO, the block send to the block device. For the system is divided into two, that is IN and CS. For the IN, the number of interrupt per second, and then for the CS, the number of context switch per second. For CPU is divided into 5 part, that is US, SY, ID, WA and ST. For US, time spent running non-kernel code. For the SY, time spent running kernel code. For the ID, time spent idle. For the WA, time spent waiting for input output. Okay, for the last ST, time stored from the virtual machine. Okay, let we start to demonstrate the information or the memory to test. Okay, let we write the VM start and then choose any variable, for example 1, and then how many time you need to count. For example, I want to count 2 times. Okay, it will show the information of your memory. Okay, this is for the first counter, and then this is for the second counter. Because I decide to count 2 times, it will pop up 2 times. Okay, for the procs RNB, the first and the second count it same. And then for the memory, SWPD, free, buffer and cache, the information for the first counter and the second counter also be same because it uses same memory. For example 1. Okay, for the swap is SI and SO. SI and SO is same as no value 0 for the first counter and second counter. For the input output, for the first input output, the BO have a value that is 27, and then for the second 0 because you only click one time, and then for the second time you don't click because it count. Okay, for the system IS and CS has a different. For example, for IS, for the first counter is 15, and then for the second count is 20 because for the first and second has different time. And then for the CS also same, the first counter and the second counter is not same. For the first counter is 15, and then for the second counter is 20 because has different time. Because context switch per second, the number of context switch per second. Okay, for the CPU, the value of US difference because of the time spent running non-kernel code. For the first clock it show 0, and then for the second clock show 1 because of non-kernel code. Okay, for the rest are same for the first code, for the first clock and the second clock. Okay, let we try to use only one time of clock. Okay, right, first we write VM start, and then 1, and then the counter is 1. Okay, now it will show only, it will count only once. The information of free buff catch are same because it uses same memory. And then for the input output and for the input output is different, because for the first time I try, I use count 2 time I count the input output BI, it will show 27, and then for the second time I decide to count once, the input output for BI is 26. Okay, for BI is the block receiver from the block device, because has the different blocks, that's why it has different value. Okay, this is our important of VM start. The VM start does not require a special permission. This report as interrupt to help identify the system blockness. Lineup VM start does not count itself as a running process. Okay, that's all for section C.
For section E, which is building a simple circuit, so the first step is to write a programming code by using Python. So this is the code. Okay, so in the code, the pin has been set up, which is for pin 23, 15 and 26 has been set up here. 23 will be GPIO part up, which means GPIO pull up, down, up, and GPI for 15 GPIO in, part down, pull up, down, and for input 26 has been set up as GPIO in, which is input button. Okay, for the condition, while true, if GPIO input 23 equal to false, then the output will be 4 and 17 GPIO high, which means the LED will be turned on. Else, if GPIO input is 15, the output will be 18 and 21. Also, the LED will be light up. And for input 26, the output will be 4 and 17. The GPIO will be low, which means the LED will be light off. So this is the output. GPIO emulator, virtual memory statistic that show the result from this code. Here is GPIO 23 part up, then the 4 and 17, the LED will be high, which means LED will be light up. 4, 17. And here, input 15, the output will be 18 and 21. So the LED will be light up at GPIO 18 and 21 here. Here. So if we push the input 26 means we push the 26 button, so the output for 4 and 17 will be blue, which means the LED like GPIO 4 and GPIO 17 will be light off.
Okay, for the last part is the 5 frequently asked question, which is the important part of the project. So let we see the first question. The first question is, what is the function of the VM stack? And then, how do the VI knows the number of block read from the block device? And then, why do we need to insert a variable for the VM stack in the section C? The fourth question is, what happens if we use the other version rather than Debian 32 bits? And the last question is, what do the exception code do in the GPIO testing? So that's all the 5 frequently asked questions from us.
Thank you.
Thank you.